question, which is what is AI ethics or why it is basically required. So AI increasingly has an impact on everything from social media to healthcare. You can see the use cases on the screen. It ranges from left to right, all the fields. Now, AI is used to make your credit card decisions, to conduct video surveillance in airports, to inform military operations, and other very, very critical parts, which is going to touch upon the human lives. Now, these technologies have the potential to harm or help the people that they serve. So by applying the AI ethics lens, we can work together towards identifying the harms that these technology can cause to people, and we can design our models or design our systems in order to reduce these harms, or even we can decide not to build them as well. So how does it work? So we take it from the human-centric design. So we need to understand what is this AI system is going to touch upon, who are we going to touch upon, and the intended users, are they actually getting benefited out of it? So like for any project, we need to gather the requirements. So we gather the requirements over here also, but something beyond the requirement is needed, which is how will the system be used by the user? That is to be understood so that we can make more appropriate applications which can deliver what the user is intended to use for. So understanding the people needs to define the problem. We need to ask ourselves, as a team, we need to see if the solution which we are going to provide is going to help the user. If we can ask few questions, and all of these questions should result in yes. If any of them says no to you, and if you find the answer is no, maybe AI is not the right solution for you. So will people consider our outcome as a good solution, or will non-AI rule-based solution can be possible over here, which can be cheaper and faster as well? So is our AI task what people would consider laborious or boring or repetitive, so that we can ask machine to do it on behalf of them? Have AI solution proven for other similar situations? If these are answers, so these questions answered as yes, AI is what we are looking for. Now we need to consider the potential harm that the AI system could cause, like the creativity. If it is stopping the creativity of a student, and we are trying to measure something for the student where his creativity is going to be capped by the AI system, then we have to see, is it the right solution or not? So we should not be harming the potential users. We need to prototype, start with non-AI solution, provide ways for people to challenge the system. So now here it comes, we can create a platform which will work upon anonymously. Now in that case, are we applying a feedback loop for the system so that humans can interact to it, come back and say where it is not performing as per the expectation? So there should be a feedback loop, like Facebook or Twitter provides a challenge, the potential block put by the system, and there is a challenge system where you can interact with the machine and say, okay, this block is not right, and you can raise a challenge. So these AI systems should have some feedback loops attached to them. We need to build a safety measure as well, wherein we can say, I've got a team, we create a red team who plays a person who try to break our system. So what happens if somebody is trying to break our AI system? Our system should not fail. So those red flags should be highlighted in the beginning by this team to handle it. Now, during the journey of collecting the data and producing the whole system, there are a lot of places where a bias can happen. Now, what is a bias? Bias could be like 6 types I mentioned over here. You can have more biases as well. The biases is something wherein, let's say, we say that the data is collected from the world perspective. Now, the world is not fair for everyone. There might be a cases where the data or the users for which the data is being collected is biased, which can cause a historical bias. There could be a set that the sample is being collected and it has got some representational bias attached to it, which can occur when the data set which we have collected is poorly designed or do not represent the people the model is proposed to serve. Or we can have a measurement bias, aggregation bias, evaluation bias, or the deployment bias. Now there is a talk about fairness, which says that the model which we are building or the application which we are building should be fair for the users. Let's say the fairness could be in terms of demographic parity or statistical parity. So a non-profit organization over here is organizing an international conference, and 20,000 people have signed up to attend, the organizers write a ML model to select 100 attendees who could potentially give interesting talks at the conference. Since the 50% of attendees will be women, then the model, if we choose up a model and say model will choose the 100 people, it should have 50% selected speakers as women. So it should have demographic parity or the statistical parity attached to it. We should give equal opportunity, which means when the model is recalling, it should recall for each group equally. Now, what the recall would mean in this case is, let's say you wanted to have a model for medical science, wherein you say a person has got a disease or not a disease. The reality is that if 100 people are going for a medical test, very few, let's say less than 5%, will be actually having a disease. Now, the data is already biased. When the data is biased, machine will try to learn or understand the scenarios where people are not having a disease more than people having a disease. Now, the equal accuracy says that whenever the model is working, it should be accurate enough for each of the group. The model might not be 100% accurate for everything. If it is 90% accurate, we are okay with 90%, but that should be 90% for every type of groups which we have got. So fairness has to be provided. Like group unawareness was where we talked about that if there is a variables that are going to cause some bias among those groups. So can we remove those variables and talk about that the solution will not be impacted because of any variable that could cause bias in the system or unfairness in the system. Now, what happens, why these ethics becomes challenge? The ethics become challenge at the point where we move from the statistical old style model to deep learning models. Now, with the deep learning models, the thing becomes is the explainability reduces to a large extent. The original models or the statistical models previously were able to explain things like if something has been predicted or something has been learned by the machine, what is it learned? How the machine is able to predict. When it comes to a deep learning level, the models becomes very complex and the explainability reduces. And that causes a lot of fear in the system or in the professional community that how do we handle biasness or how do we make the system is fair with deep learning models. So for that, we have got on GCP Explainable AI, which can explain, debug, refine, verify, or present what the model has been built. So when we talk about explain, we are saying that it can explain why individual data points. So I'm talking about individual data point groups. Yes, it can, but it can go to the individual data point level and say why something has been predicted like that. So for a person A, if we are saying that he might get defaulter if we pay, like if we give him a credit card, why I'm saying so. What is making it out? If we can debug some odd behaviors from the model. Odd behaviors could be for a particular set of images. Like if I'm looking for a particular disease, there is a disease present in, let's say, an X-ray or an MRI, but the system is again and again saying that this person do not have a disease. So can we debug it? Can we go deeper and say why the model is saying so? Yes, we can if we can explain what is happening inside the model. Can we refine? So for all these cases where we see that there is some disparity, it's not matching to the expected results, can we refine our model? Can we fine tune it? Yes, we can. And then can we verify the model's behavior is acceptable? Finally, whatever the model is, can we present a gist of it? Can we say what the model has learned? So those things can be explained by using explainable AI part of the GCP. And there are multiple frameworks for it, depending on what type of algorithms we are using, what type of data types we have got. So we can use integrated gradients, tree shape, sample shapely, or exact shapely, which can extend from TensorFlow to XGBoost to any other models, including tabular data cross for images and text. Integrated gradients can be used. There are tools like What If tool. Now, What If tool is to analyze your models, be it a TensorFlow, XGBoost, scikit-learn model, which you can deploy on the AI platform. As the AI model grows in complexity, understanding the inner working of a model makes it possible to explain and interpret the outcome driven by AI. As a result, AI explainability has become a critical requirement for most organizations in industries like financial services, healthcare, media, entertainment, and technology, especially from those industries where there is a requirement from, let's say, a government requirement that if you're performing something, how you're performing it, explain it. So that explainability is required as part of the requirement system itself. Now, using this what if tool, you can build effective machine learning models and ask a lot of questions to them as well. Like if the model is doing something, how it is doing, why it is doing so. We can experiment with multiple features. Features here are the variables, which are the input variables for any course. Now, what if I could change a value of a feature? If I'm changing the value of the feature, how is the output changing? How is if some features are added, removed, or a new variable, let's say a new data point comes in, how will it impact my model? Or let us flip the question. How do model outcome changes along with the value of the features? If those are being answered, the machine is not only learning, but you're also explaining you what are the rules behind the system. We can optimize for the fairness by knowing all this using the what if tool. What values, like about the fairness, what values must be there for the thresholds for our models to achieve a desired statistical definition of a fairness. When we say something's to be fair, how the thresholds have to be moved along so that the equal opportunity or the equal fairness can be achieved. Will this model, if we ask about it, will this model perform equally well for all slice of evaluation data? Let's say there is a group of young people or the old people, and we have got different ethnics in our data set. Is it going to perform fair or equal for all? We can compare multiple models. We can use like comparison of the model, saying one model is doing this and the model is doing this. We can compare them based on the data points, subset of the data points, or even on a specific data point to say how one of the model is behaving and how it is different from the other model. It will give us a greater extent to choose the right set of model for our users. So we can reach to deep insights when we evaluate multiple experiments with different models. We can get feedback from the business stakeholders saying this model is more appropriate to their use case, and we can debug models via comparison as well.